Hi guys, welcome to Gatematic. In the previous lecture we saw the concept of three-phase fault current and derived some expression of fault current IF is equal to EF upon total impedance Thevenin impedance plus ZF, that is the fault impedance. Also we saw the concept of short circuit MVA and we derived an expression that is short circuit MVA is equal to fault current in per unit multiplied by the base MVA. Now in this lecture we will move forward and we will try to solve one question of three-phase symmetrical fault, and we will see the different types of fault current, pre-fault current, post-fault current and fault current at that bus. Try to watch from start to end. At the end I will give you the concept of how to reduce any kind of complex circuit within a fraction of a second and how to find the fault current just by using the Thevenin equivalent circuit. These all things we will discuss in this lecture. So let's get started. See this question here, single line diagram is drawn. Here generator is connected to transformer T1 and T2 are connected and motor is connected, and the rating of generator and motor are same, that is 25 MVA at 11 kV. Means this is at 11 kV and this is at 11 kV. And reactance of generator and motor are given, that is 15%, that is 0.15 per unit at 25 MVA base. Similarly for transformer T1 T2 rating is given 25 MVA at 11 by 66, means this will be 66 kV and this will also by 66 kV. Okay, so mainly this is T1 is the step up transformer and T2 is the step down transformer, and per unit reactance is given, that is 10%, that is 0.1 per unit. Similarly transmission line is also given in per unit at 25 MVA and 66 kV base. Here original voltage is 66 kV and transmission line per unit reactance is also given at 66 kV. So each and every parameter is given at 25 MVA. Okay, so no need to convert on other base because we can easily draw the reactance diagram of this, because each and every parameter are defined on same base. Got it? Now see the question what is saying. Motor is drawing 15 megawatt at 0.8 power factor lag at 11 kV. Motor is at 11 kV, means terminal voltage at motor is 11 kV, and suddenly three phase symmetrical fault occurs at bus 4, means at the terminal of this motor a fault occur, three phase fault occur. Then I have to find the pre-fault current in generator and motor. Pre-fault means before the fault what was the current in generator and motor first. Second, post-fault current in generator and motor. Suddenly when fault occurs, then what will be the current in flowing in motor as well as generator, that we have to find. And third is the fault current at bus 4. These three things we are going to find in this lecture. Now based on what we have studied till now, first what we have to do, we have to draw the reactance diagram. Before finding the pre-fault current and post-fault current, first you have to draw the reactance diagram. So as I already explained you, the reactance diagram will look like this. Is my reactance of generator, this is my EMF of generator EF, and the reactance of generator is given, that is equal to 0.15 per unit. This will be J. Here transformer reactance is given, that is equal to 0.1 per unit. This is my bus 4 and this bus 4 is at 11 kV and I am choosing the base voltage at 11 kV only. So 11 by 11 will give me the bus 4 voltage, that is equal to 1 per unit. This is my motor and this is my EMF induced in motor EM, and let us say this is my EG. So this is my reactance diagram where reactance of motor is 0.25. Now see, according to the question, it is saying that pre-fault current I have to find, post-fault current I have to find, and fault is occurring at terminal 4, means at this point. This is my terminal 4 point. And voltage at this point, by choosing base of 25 MVA and 11 kV, the voltage at this point will be 11 by 11, that is 1 per unit. If I will have to write the voltage in per unit, then it will be 1 per unit. So this is my pre-fault reactance diagram. I can say pre-fault means whatever the parameter, whatever the diagram I am making, that is before the fault, before the occurrence of fault. And first question is saying that I have to find the pre-fault current in generator and motor, means I have to use this reactance diagram only, right? So let me draw the equivalent of this. I need to find the fault current, and basically fault is happening at bus 4. So I can say that these all reactance are in series, isn't it? So 0.1, 0.1, 0.1, that is 0.3 and it is 0.15. So overall this will be my EG, this will be my J 0.145 in per unit, and this is my bus 4. I am interested in bus 4, that's why I am writing like this. and voltage at bus 4 is 11 kV, so I am taking the base voltage also 11 kV, so 11 by 11 will give me per unit, that is 1 per unit. This is my J 0.15 per unit, that is the reactance of motor, and this is my EMF of motor. Now according to question, it is saying that motor is drawing 15 megawatt at 0.8 power factor lag at 11 kV, means I am talking about this bus 4. Okay, motor is drawing power from bus 4, that is the 15 megawatt, and I have chosen the base MVA 25 MVA. Is it fine? So what is the power in per unit? The power in per unit will be equal to, motor is drawing, that is 15 megawatt upon 25 MVA. Is it fine? So it will be equal to 0.6 per unit, and guys, this is in per phase. Please remember this, because if you will divide the numerator by 3 and denominator by 3, it will give you 0.6 per unit only. So whatever the per unit parameter is defined, that is in per phase only. Okay, so I got the power taken by this motor, so I can easily write root 3 times of VL into IL in per unit, that will give me the 3 phase power in per unit, and this will be my 3 phase. So per phase power will be what? So per phase power will be what? Per phase power will be V phase into I phase, that will give me per phase power, that is equal to 0.6 per unit. Is it fine? So from here I phase, let us derive this V phase I phase into cos phi also, because we are talking about the active power. So I phase will be equal to 0.6 by V phase. Per phase voltage at this bus 4 is 1 per unit, so multiplied by 1 multiplied by cos phi, that is 0.8. So it will give me 0.75, and this is lagging in nature, that is minus 36.86. So I got the pre-fault current. Pre-fault means before the fault current, that is equal to 0.75 in per unit at an angle of minus 36.86. So this was my answer of this first part. First, pre-fault current in generator and motor, and generator as well as motor, same current will flow. Now suppose you have to find the current in actual value, that is current in ampere. So we know I per unit is nothing but I actual upon I base. So I have to find the I base. I base is nothing but total MVA upon root 3 times of V base. I can write like this, and this way V base is line voltage. This is my 25 MVA multiplied by root 3 times of base voltage I took, that is 11,000. So I base I will get, that is equal to 1.312 kilo ampere. Okay, definitely. So pre-fault current I pre-fault I will get, that is equal to, in ampere, I per unit multiplied by I base, I in per unit multiplied by I base, that will give me 0.984 kilo ampere. So I got the first part, that is the pre-fault current in generator and motor. Now I need to find the post-fault current. Post-fault current means when fault occurs, three-phase fault occurs at this bus. This is my bus 4. Then what will happen? So let me omit this. So finally I am getting the pre-fault current, that is equal to 0.75 in per unit. I don't need to find in ampere. You can find just by finding the I base that we got, that is equal to 1.312 kilo ampere. So let me write here I base I got, that is equal to 1.312 kilo ampere. So by multiplying the fault current in per unit multiplied by base current, you will get the actual value. Now see, this is my pre-fault reactance diagram. Okay, so I don't know the value of EMF here, but I know the value of fault current. Definitely we can find the value of EMF of generator as well as motor. So see here, this is at 1 per unit according to the question. So if I will apply the KVL in here at this in this loop, then it will be equal to EG is equal to, this is at 1 per unit, so it will be 1 per unit plus J 0.45, this is my reactance, multiplied by the current flowing in the circuit, that is equal to 0.75 at an angle of minus 36.86. Is it fine? And this terminal voltage is at 1 at an angle of 0 according to the pre-fault case. We take the base voltage 11 kV, so 11 by 11 will give me the 1 per unit. So finally EG, the EMF in the generator will be equal to 1.232 at an angle of 12.656 degree. See, when I was dealing with the concept, then I told you that the generator is having delta at an angle of delta, that will be positive. Okay, so see here, generator angle I am getting, that is in positive. Similarly we can find the motor EMF also by applying the KVL in this. this is my 1 per unit and the current direction is from left to right, so it will be 1 minus J 0.15, that is the reactance of motor, multiplied by the current flowing in this, that is equal to 0.75 at an angle of minus 36.86. So finally the EMF of motor will be 0.936 at an angle of minus 5.5. So see here, motor is having angle that is in negative and generator is having angle that is in positive. So I told you while dealing with the concept that you will get the delta angle positive in case of generator, in case of motor it will be in negative. So we got these things. Okay, so pre-fault current, pre-fault EMF across motor as well as generator we got. Now we will see what will happen in post fault. Post fault means if suddenly fault occurs at this bus, this is my bus 4 whose voltage is at 1 per unit, and if fault occurs at this point, then what will the voltage? The voltage will become 0. Why? Because this will be connected to short circuit, this will be short circuited. So whenever any terminal is shorted, then the voltage across it will be 0, right? So let me draw the post fault reactance diagram. The post fault reactance diagram will be something like this. So if fault occurs at this bus, means this is connected with this, three phase fault will occur, then either it will connect to the triple line or triple line to ground. So this will be sorted, this bus 4 will be sorted something like this. So if this will be sorted, means this, see, this motor will deliver energy to the system as well as this generator will deliver energy to this system. That means all the current flowing in generator will be going in short circuit as well as all the current flowing in motor will be going in short circuit path. Got it? So initially during pre-fault means whenever the fault when the fault was not occurred, then on that time the motor was taking power. See here, the direction of current was something like this, means motor was taking power. Now suddenly if fault, three phase fault occur, then this motor is having some kinetic energy. Okay, so that kinetic energy they will supply in the form of electrical energy to this short circuit path. Okay, so what will be the fault current? Fault current will be equal to the fault current produced by this motor and fault current produced by this generator, and this is my IM after the fault. Whatever the diagram I made, that is the after fault, or you can say post fault, right? Pre-fault parameter I already found. So when sudden short circuit fault occurs, then definitely this EEG will be remain as it is. EG will be equal to 1.232 at an angle of plus 12.656, and this EMF will be equal to 0.936 at an angle of minus 5.5 degree. So I can easily find this is sorted part, this is something like network circuit. Okay, so what is the value of IG? IG will be equal to EG upon the reactance, and see here in this case the reactance is J 0.45 only. And similarly, what will be the value of IM? The value of IM will be equal to EM upon J 0.15. And what will be the value of fault current? Fault current will be the summation of IG plus IM. Okay, and this all will be in phasor. In this way we can find the value of post fault current in generator and motor as well as fault current at bus 4. So post fault current in generator and motor will be Eg upon J 0.45 and Em upon J 1.15, and fault current at bus 4 will be Ig plus Im, and these all are calculated at in phasor domain. Okay, the value of Ig will be 1.232 at an angle of 12.656 divided by J 0.45. Apply on calci, the value of Ig you will get, that is equal to 2.737 at an angle of minus 77.35. This is my Ig. Similarly, Im will be equal to Em upon this, and Em you have to take in phasor, 0.936 at an angle of minus 5.5 divided by J 0.15. Im you will get 6.24 at an angle of minus 95.5 degree. Okay, once you got the value of Ig and Im, then If will be equal to the phasor sum of Ig plus Im, and this you will get, that is equal to 8.88 at an angle of minus 89.99, and these all parameters are in per unit. Now if you want to find in ampere, just multiply with by base current. This is my base current, and base current will be remain as it is before fault as well as after the fault, because The base MVA is fixed and base voltage is fixed. So always keep in mind in NAT type of question, numerical answer type question, that see the unit of current. If the unit of current are in per unit, then take it as it is. If the unit of current are in ampere, then you have to multiply with the base current in order to find the actual value of fault current, current flowing in generator and current flowing in motor. Got it? In this way we can solve this question. Now the main problem is, if you will find the solution of these questions, then definitely it will take 10 minutes. I can assure you it will take 10 minutes. Why? Because you have to find the value of EG and EM. Without finding the value of EMF across generator and EMF across motor before fault, you cannot able to find the fault current after fault. Suppose EG is unknown, so EG will be unknown, then we cannot find the fault current. That is the reason this method is little bit complex. So in order to reduce the time, in order to reduce the complexity, what we will do, we will understand the concept of Thevenin equivalent. What do you mean by this Thevenin equivalent? Just try to understand. This is really important from gate point of view. How to solve any kind of three-phase symmetrical fault by Thevenin equivalent, that is really important to understand. Okay, watch this lecture, you will not have any problem at the end. What does Thevenin equivalent say? See, this is the diagram that I drawn, that is during pre-fault. Pre-fault means before the fault, the diagram was, reactance diagram was something like this. Okay, so see here, pre-fault, during pre-fault the voltage across bus 4 was 1 per unit, right? So by using substitution theorem, I can say that this is at 1 per unit, whose polarity will be something like this. I can replace like this, or I can attach one voltage source whose value will be 1 per unit at this bus 4. I can write like this, and this is taken at for any particular value of time. The value of the polarity of EG is plus to minus, EM is something like this, and voltage across this bus 4 is 1 per unit. Means by using substitution theorem, I can attach or I can connect the ideal voltage source having 1 per unit value. I can write like this. This is my pre-fault system. Also I can say that pre-fault current will be in series only, means this will be 0.75, this will be my 0.75, this will be my 0.75, means no current is going into this voltage source. Then only I can substitute by one ideal voltage source, right? Now see the second diagram. How the second diagram I am making? I am short circuiting this EG, okay, and only there will be some reactance J 0.45, and this will be my opposite polarity having same value 1 per unit. I am short circuiting the motor also, EMF of motor also. This is my J 0.15. So these two reactance diagram I made. Now add these two. What will happen? Just try to understand. According to superposition theorem, if I will add these two reactance diagram, then what I will get? See, this is my EG, this is my reactance, that is J 0.45 per unit. Here 1 per unit having voltage source something like this, and this is also having 1 per unit having voltage source having opposite polarity something like this. I am adding both the system by using superposition theorem. This will be J 0.15 per unit, and it is having EMF EM. I can write like this. Means pre-fault reactance diagram plus this diagram, if I will add by using superposition theorem, then what I will get? I will get this diagram. Okay, now see it clearly what this diagram saying. 1 per unit plus 1 per unit and minus 1 per unit will cancel out each other, means this is sorted. Okay, so this is nothing but the post fault diagram. Okay, when sudden fault occurs at this bus 4, means this is representing something like post fault diagram only. So what is the conclusion? The conclusion is, if I will add this current, the current produced in this reactance diagram, and add this current produced at this reactance diagram, then the resultant will be giving me post fault reactance diagram, the current produced in post fault reactance diagram. So what is the benefit of this? I made this circuit, this is nothing but Thevenin circuit only. I short circuit the voltage source, and I applied the voltage having same voltage 1 per unit at bus with different polarity, and I am finding the current. So this is nothing but the Thevenin equivalent only. So that is what the concept I want to explain here. See, now it is easy to find the current. I already know the pre-fault current, that is equal to 0.75 at an angle of minus 36.86, and this is flowing in generator from left to right, and from motor, and in motor it is flowing from left to right having same value 0.75 at an angle of minus 36.86. Now see, I can easily find the current across here. How? Let us see, let us name it as, this is my voltage source having polarity something like this, means current will flow something like this. This will divide into two parts. Okay, so let us say current flowing here is del Ig, and let us say current flowing here is del Im. Okay, so what will be the value of del Ig? Del Ig will be equal to 1 per unit divided by J 0.45. This will give you minus J 2.22 per unit. Similarly, what will be the value of del Im? Del Im will be equal to 1 per unit divided by this, so 1 upon J 0.15, 6.67 per unit. So see, within a fraction of second I can easily find the del Ig and del Im. Why? Because I know the voltage across this bus. Only I have to attach that voltage with opposite polarity, right? So current will flow opposite, that is what it is happening here. Okay, so once I got the del Ig and del Im, then I can easily say what is the current flowing in generator. See, post fault current, the current flowing in generator, actual current direction is something like this, and in post fault reactance diagram the current flowing in motor will be something like this. So let us say this is my Im and this is my Ig. Now add these two, what will be the value of Ig? Ig will be, just try to understand, this is flowing from left to right and del Ig is also flowing from left to right. So overall these two are getting added, so 0.75 at an angle of minus 36.86 plus del Ig is given, that is minus J 2.22 per unit. Add these two, you will get Ig is equal to 2.73 at an angle of minus 77.33. So the current, fault current in generator you are getting same like in method 1. Okay, in method 1 also the current Ig you got, that is 2.73 at an angle of minus 77.33. You can check that by rewinding this lecture. Similarly, what will be the value of Im? Here you have to keep in mind, see the actual direction of Im in post fault. Actual direction of Im in post fault is from right to left, and see here this current, pre-fault current in motor is flowing from left to right, and in Thevenin reactance diagram it is flowing from right to left. So what will be the actual Im? The actual Im will be del Im minus the pre-fault. So it is equal to del Im minus I pre-fault. Got it? In while finding the value of Ig, I was getting del Ig plus I pre-fault. Okay, but here while finding the per unit post fault in motor, it will be del Im minus I pre-fault, because after fault the direction of current in motor will change. So it will be equal to 6.24 at an angle of minus 95.5. So by using this Thevenin concept also, you are getting the same current in generator as well as motor as well as the fault current. So I can easily find the fault current here. It will be Ig plus Im. So fault current will be phasor sum of Ig plus Im. Okay, so this is really important to understand. See, in method 1 what I was doing, in method 1 I was finding first the pre-fault current, okay, then pre-fault EMF across generator, then pre-fault EMF across motor. So three parameter I am finding in method 1, and after finding this I was short circuiting this during post fault, and I would finding the Ig and Im, that is Eg upon this one J 0.45 and Em upon J 1.15. Okay, so what was the difficulty we face in method 1? In method 1 we have to find the extra parameter, that is the value of Eg and Em. Now see, in Thevenin equivalent circuit you don't have to find the value of Eg and Em, only you need to find the del Ig and del Im, and within the fraction of second you can add in order to get the fault current in generator as well as fault current in motor and as well as total fault current. This concept is really important guys, please try to understand. If you are not understanding, just tell me, or you can rewind this lecture. If you will see the 1 or 2 times more, then you will understand what I am doing. I am just applying this Thevenin circuit. I am just making a Thevenin circuit, and after that I am applying the superposition theorem. So if I will apply the superposition theorem, then definitely I will get the fault current within 1 to 2 minutes. We don't have to find the value of EG as well as EM. It is not necessary. But if you will go through the method 1, then you have to find the value of EG as well as EM. Okay. So that's all about this lecture. In the next lecture, we will see the previous year gate and ES problem related to three-phase symmetrical fault. Then only you will come to know that whatever the concept I have delivered, that is more than enough to solve the gate as well as ESE question. So if you guys understood the concept, then please like this video, and if you are having any doubt, then you can ask in the comment below or join our Facebook group for doubt solving.